The final concept I want to go over with regards to the standard normal curve is that sometimes you aren't given the z. A lot of these problems are set up so that you're given the z and then you have to find the probability. But sometimes the problems go in the other direction. That is, you're given the probability and you have to work back to the z-score. So if you're doing it in the inverse like this, that's called a probit function. So a probit function just means you're given the area and you have to find the z-score. So let me just give you an example and make it very clear. So what if you wanted to know, for this math SAT score, you wanted to know what SAT score do I have to get in order to be in the 90th percentile of math SAT scores? And again, assuming that we're on, we have a mean of 500 and a standard deviation of 50. So how are we going to solve this problem? So we need to know what's the z-score that goes with the 90th percentile. 90th percentile is just an area. We want to know what's the z-value that corresponds to an area of 90%. So the 90th percentile for math SAT scores is going to be somewhere over here. That means that 90% of people are lower, so that means our area to the left is 90%. So we're going to go to the z-chart. We're going to find the area of 90% and work backward to the z-score. So if I go to my z-chart and I literally have to scan around with my eyes until I find 0.90. And you'll notice that it comes 0.8997. You also get 0.9015. 0.8997 is the closest to 0.90. So I'm just going to pick that one. So that corresponds to what z-score? If you scroll over, it's a 1.28. So that corresponds to a z-score of 1.28. So in order to have 90% area to the left, you need a z-score of 1.28. So to be in the 90th percentile for SAT scores, you need to be 1.28 standard deviations above the average. So what is 1.28 standard deviations above the average if I want to actually get the number for the SAT score that I'm going to need? Well, how would I solve that? Well, what is in this case, a standard deviation is a value of 50. So first of all, I would multiply the z-score times the standard deviation. So I want to be 1.28 standard deviations above the mean. That means I want to be 1.28 times 50 above the mean. The mean here, of course, is 500, so I'm just adding to the mean. When I calculate that out, I get that I need to have an SAT score of at least 564 if I want to be in the 90th percentile.